bit of lesson 3. And we mentioned in lab yesterday the idea about recovery. Okay? Think about what happens when you stop moving. Alright? So you've been riding your bike, or you've been running on the treadmill, or you've been playing a game. When you stop, does your breathing immediately go back to rest? Right? And your heart rate doesn't immediately go back to rest. So we have a recovery period where our body is trying to get everything back to normal. So it's trying to decrease acid levels in the muscle, it's trying to replenish oxygen to the bloodstream and move some glucose back around the body, right? There's a lot of things going on. And we've got to rebuild, remember, our phosphocreatine that we broke down, and that takes ATP to rebuild it because I have to put an energy bomb back. Okay. So there's lots of things going on that still require higher energy levels than pure rest, all right, when you stop moving. And so that additional breathing rate and that intake of air and oxygen is called EPOC, right? Excess post-oxygen consumption. So after I've stopped exercising, I keep breathing, but really I'm not doing enough work to require that amount of oxygen, right? But I've got all these other jobs going on. So it used to be called the oxygen debt. When I was in college, it was the oxygen debt, and it represents energy that we borrowed at the beginning of the aerobic exercise that we got through anaerobic metabolism. All right, and I'll show you, it's easier, I think, to get this when we look at the diagram. Right? All right, so here's rest, all right? So you're sitting on the park bench in the sun, and you get up and you start to go for a jog, right? Theoretically, jogging is aerobic, right? And so I should be making the ATP to jog aerobically, but remember we can't do that initially, right? If I've been sitting down, then there is a period of time where I don't have enough oxygen available to the system to make ATP aerobically. Does that make sense? Okay. So actually what happens when we look at our oxygen consumption is we gradually start breathing deeper and faster until we get to the point at which we're breathing and we're getting oxygen in at the level we need to do that workload. It's called steady state. So at steady state, my oxygen intake and consumption is balancing my requirement for oxygen. Right? Once you reach steady state, you can keep going for ages. So when you go for a jog, or you first get on your bike, try to remember, or the next time you do it, pay attention to the fact that the first couple of minutes feel not hard, but kind of uncomfortable. It's a little bit harder. And then all of a sudden, before you even realize it, you're kind of in this rhythm, and it starts to feel easy, right? And then if you stay at that pace, and you stay on a level surface, you you don't change the intensity, you could keep going at that pace relatively comfortably for a long time until it became uncomfortable, right? But those first few minutes are a little bit difficult. You have to kind of motivate yourself to keep going because you know it's going to ease up, right? Those first couple of minutes are represented by this darker shading here, right? That's the period of time where the work that you're doing can't be supported by aerobic metabolism. So that's called the oxygen deficit, and we supply our ATP during that part of the curve anaerobically. Okay? With me? Right. So I jog along in my steady state. If you hit a hill, then you're going to have to use a little bit of anaerobic metabolism to deal with the hills, so the hills are always a little bit harder. Right? And then you stop your jog. You come to the end of your distance or your time, whatever your decision is. But we keep breathing, right? Here's oxygen consumption. I keep breathing, I keep moving oxygen into my bloodstream and down to my muscle cells for some extended period of time after the end of the exercise. So this is my recovery period over here. Used to be called the oxygen debt. It's now called EPOC because it's changed a little bit from when I was in undergrad. This part of the shaded graph used to match this part, right? They used to think that you breathe harder at the end of the exercise just to put back the energy that you borrowed at the beginning of the exercise, okay? Over the years, they found out more about it, and that isn't the case. EPOC is actually a little bit bigger. So I breathe more than I need to replace what I borrowed. So the oxygen deficit is the difference between the amount of oxygen I would actually need and the amount of oxygen I have available until I hit steady state. Steady state means that all the energy I need to do that amount of work is being supplied aerobically. And then EPOC is the oxygen taken in above what I would need at rest, even though I'm not now moving. When you look at the EPOC curve, you can see that there's a quite steep, sharp bit here at the beginning, and then it tails off and becomes less steep. So this steep part here is called the rapid phase. Lasts for around 2 to 3 minutes, and what they think is going on during the rapid phase is the rebuilding, the resynthesizing of phosphocreatine in the muscle cell. Right, so that at the end of the run is putting all the phosphocreatine you broke up over here back together so that it's available the next time you need it. The slow phase, so once we get a little less steep, can last anywhere up to several hours, right? So depending upon the workload that you did, then you actually may be breathing a little more deeply or a little more rapidly for quite a long time. And in that slow phase, there you are metabolizing lactate. So I mentioned earlier that lactate can be used as an energy source. So that starts to occur. We've got to get rid of that lactate. So we move it around the body, or we break it down in the muscle cell, and we start to use it as, turn it into like a carb, and we can feed it into glycolysis. We've got to restore oxygen to the muscle. There's a little bit of oxygen sitting in the muscle cell all the time. And we want to make sure that all our hemoglobin in our blood has plenty of oxygen on it again, so we've got to do that. And partly that extra breathing is dealing with things like elevated hormones, elevated body temperature. I've got to bring all that back down to a resting state. Okay. So, how big the area under the curve is more dependent upon how hard you were working than it is on how long you went for. Because once you're in that steady state, you can go for a long time. So it's how hard are you working dictates. So intensity is more important to EPOC than duration. All right, so the idea of EPOC is particularly relevant when you're looking at interval type games or activities. So either actual interval training or something like basketball or soccer, right? Games where you've got a short, sharp anaerobic burst and not very much time to recover before the next anaerobic burst. Because what we find is if I'm doing these short, sharp anaerobic bursts, then in between those, if I do some light to moderate aerobic exercise, I recover faster than if I do nothing. So in a soccer game, if I have to sprint down the field with the ball and I lose the ball or I pass the ball, it's better for me to jog on the spot or walk around or keep moving than it is to stand still and watch what's going on in the game. If I want to be ready to sprint the next time the ball comes to me. So an active recovery, so if I'm doing intervals, it's better to do your short sprint and then a walk or a jog, and then your short sprint and then a walk and a jog, than to do a short sprint, stand for 5 seconds, do another short sprint, stand for 5 seconds. So when you're doing interval training, that recovery period in the interval should be something where you're moving, not standing still. The suggestion is that it might be because it's easier to move the lactate out of the muscle tissue at that point if you keep moving. And they give some ideas of the kind of intensity you want to look at for your recovery period. The key is, remember our lactate threshold, right? That's the point at which I'm working anaerobically and producing lactate. So your recovery, your active recovery has to be at an intensity that is below your lactate threshold. So depending on how fit you are, your active recovery could be a little more active than someone who is less fit. There doesn't appear to be any difference between a trained person and an untrained person when you look at lactate recovery, but there is some literature that says if you're more aerobically fit, that your ability to recover is better after certain forms of resistance exercise than someone who is less fit, which is quite an interesting idea because we consider weightlifting as an anaerobic activity. But what the literature is suggesting that if your VO2 max is bigger, if your aerobic capacity is better, in between those heavy sets, you'll recover better than someone who is less fit. So that provides an argument for doing some aerobic work, even if you're doing weightlifting, which is not at all aerobic. The literature's really pretty hazy around here. Part of the problem is that you've got people studying who have a particular interest. And so they will look at what they want to look at. So we know that this aerobic capacity improves recovery for certain types of resistance programs, but we don't know if it helps all anaerobic recovery. You can postulate it does, you can hypothesize it does based on the other literature, but we don't know because no one's looked at the other activities. Right? So it can get a little frustrating when you're reading literature like that because they say, well, it may, or possibly, or perhaps this, and you want to go, no, will someone just tell me yes or no? Does this help or not help? Don't tell me it might help, right? But that's the way, that's what you're going to come across as you read, right? Because we don't know the answer in all the cases. No one is going to say yes, it will help, or no, it won't help. So just be ready for that. And that's just some data to show. So the red, here's the end of exercise. The red is what happens to your plasma lactate levels if you do an active recovery. Right? And here's what happens if you do a passive recovery. Think about this recovery time. What if you don't have 50 minutes to recover before the next bout is due? Right. So if you're in a game scenario, getting this dropping down quicker might be very helpful. Right? All right. So, review. Any questions that you have just off the bat on anything you want me to go over before you start your actual review stuff? So what I like to do in the review at the end of your chapter, it has a block of questions to help you identify what you do and don't understand about the chapter. All right? So what I do is I go through those questions, I pick out the ones that I think are the most relevant. That doesn't mean that the rest of the questions are not relevant. It's just I pick out the ones that are the really important. Like if you look at that question and you don't know what it's talking about, you're in trouble for the exam. Right? And you're going to get into teams. I'm going to give you the list of questions. You're going to answer the questions and then we'll see which team wins. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. 3 teams of 4. Off you go. Get yourselves into 3 teams of 4 while I write the questions up. Or 4 teams of 3 if you feel that way inclined. I don't mind. But move around, get grouped, get ready.
Yeah, you're good.
Is that good?
Yeah.
Okay, thank you.
Just don't write any higher than that.
Okay. Bless you. You probably can make more noise than this, guys. So what have we got? 1, 2, 3, 4. You two are on your own? Did I miscount? Oh, I see, they did a 4, so they abandoned you. Damn. The girls all ganged up and left you out? Ooh, harsh. All right, I'm going to turn this off and then someone please remind me to turn it back on when we do the end.